Infinity, the very concept that has captivated the imagination of human beings for over centuries. It is the concept that has led to scientific revolutions and cultural revolutions as well. It is the ultimate humbling experience when you look to the night sky to fathom the infinite heavens above you and to think whether other life forms exist in the cosmos, or while studying number theory and contemplating on the paradoxes of infinite primes. Infinity is the ultimate pedigree, is the ultimate flag that shows how little we know about anything in life. But let me tell you this, if there is infinity that is coming up in any field, in physics especially, that means we have still yet to learn a lot. In relativity, for example, the place that we don't understand inside of a black hole, a singularity, a point of infinite density is the point, is the research field that everyone is working on, because it is the very point that we don't understand. It is the very point that we want to explain. So infinities aren't just imaginations, are just flags that shows how little we know about that concept. Because we can't explain infinity. That's why we call it. That's why we call something infinite when we don't understand it, because we can't calculate it. It diverges. It doesn't make sense. We can't observe it in a laboratory. We can't conceptualize anything about it. So infinity is the ultimate disease in our thinking. We need to get rid of it somehow in our conceptualizations. In mathematics, the modern revolution in mathematics is dependent on how we escaped this definition of infinity in calculus. So, in order to give an example, the convergence definition, for example, in calculus, Cauchy famously used, for example, in high school, everyone uses epsilon goes to infinity and those kind of formulations, but it is very ill-defined. The modern mathematicians, starting with Weierstrass in 19th century, whom was actually a high school teacher in Germany at the time, but of course at those times high school teachers were very, very advanced knowledge, and mathematics weren't as developed as today, so it was quite easy to at least get accustomed to the contemporary science at the time. So Weierstrass was able to capture what we attained from infinity, from calculus, with his epsilon delta definition, and it revolutionized mathematics. And today mathematicians try to escape infinity as much as possible. In physics, as I told you, singularity is a point of infinite density. It's a point that we don't understand. In quantum field theory, we try to escape divergences in our calculations, and we call it renormalization. It was Gerard Hooft that showed this, and that's why he is so well regarded. And still, we are trying to develop techniques in quantum field theory to escape this renormalization. We are trying to come up with renormalization procedures just to escape this concept. So infinity is the ultimate gift as well as it's the curse. It may be the ultimate reason that we won't ever completely understand the universe, because whenever we try to extend our models to escape this concept, it seems like it keeps popping up from another place. So we'll see. So thank you.